and then we update. Okay, now that we are sure that the root lies between an and xn, because the product of f of an and f of xn is negative, therefore we know that our an plus 1, okay, let me just put something here just to remind us. Okay, so this is what we have initially. We have a naught and then we have b naught. We have computed x naught, and then we have found out that f of a naught and f times f of x naught is negative. That means that the root lies in here. So that means that our a1 on the next approximation, the next interval, we are going to say that our a1 is going to be equal to the value here, which is a naught, and then our b1 is going to be our value of x naught. Okay, so that means that on the next approximation or the update here, I would like to call this one here where we have an plus 1, and then this is bn plus 1. Okay, remember n is 0, therefore an plus 1 is going to be a1, and then bn plus 1 will be b1. So our a1, we have said that it is the same as a naught, which is 2, and then our bn plus 1, we have said it is going to be xn, which is 3. Okay, so here we just inherit when now on the next iteration, we know that a1, when n is 1, this is a1. We have already said that a1 is 2, so we put that as 2, and then our b1 is 3, so that is 3, and then we continue. So we have already found out that f of 2 is negative 9, and then we already found out that f of 3 is 1, and now we compute. Of course, you can see already that these are all different signs. We already seen that even previously. So here we compute xn, which is 1/2 of an plus 1, which is 1/2 of 2 plus 3, which is 2.5, and then we compute f of xn. Please check to make sure that this was correct. This is negative 5.875, and then here we check f of an, this one here, and f of xn. What is the sign, the product of f of an and f of xn? So we see this is a negative, this is a negative, so this is a positive. Now that this is a positive, we know. Okay, let me just illustrate it here. Now we came and found that now, okay, so this is what we, oh sorry about this. Okay, this is going to take a while. Let me just do this. Okay, so initially we had a naught, b naught, and then we found out x naught. Then we had this as a1, and then we had this as b1. Okay, and we calculated x1. This is where we are, and now we have found that the product of a1, okay, this one here, and x1, this one here, oh sorry, x1, this one here, is positive. Okay, so we have found out that the product of f of a1 times f of x1 is positive. This product here is positive. That means that the root does not lie in this interval, rather the root now lies in this interval. So we are going to set our a2 to be equal to x1, and then we are going to set our b2 to be equal to b1. Okay, so that means that, okay, you now the error here you can calculate the error here by finding, because this is xn, this is x1, and this was x0. So the error here is going to be the absolute value of x1 minus x0. Okay, so this is the absolute value of 2.5 minus 3, that is going to be 0.5. okay, so you just keep on computing these errors like that. The value here, the approximate root we get here, minus this, then here you get the value we got here, minus that, and so on. All right, so we have said here that now our a1 is going to be equal to the x1 here, because we have found that that is where the root is lying in this next interval here, that the root lies in this interval here, this one here, and not this one here. Why? Because we found out that f of a1 times f of xn is greater than 0. Okay, they have the same sign, so the root lies here. So we are saying that a2 is going to be equal to x1, and then b2 is going to be equal to b1. So b2 here is going to be equal to the value we had for b1. It does not change, this one here, which is 3. Okay, so we go on and write the next one. So the next one here, we are going to write the next one here. We shall write this is 2, and then this is 2.5, and then we have found out that bn is 3, and then you can fill the rest. This is f of f1, this is negative 5.875, and then this is f of b1, which is 1, and then you can fill this one. This is 2.75, and then we found out that this is negative 2.953. 125. Then the product here of f of 2 and x2. Where is f of 2? I mean f of a2 and f of x2. So we see that this is negative and this is positive. So this is a negative, and now we know that the root lies between a2 and x2. Okay, so in the next we shall set our a3 to be a2, and then our b3 will be x2. So that is why we shall write here as 2.75, and then this one here will be 3. Okay, all right, hold on just a minute. We have said that our b3 will be x2, and what is x2? No, x2 is actually 2.75. So this is 2.75, and then our a3 is the same value we had for a2. And what is a2? This is 2.5. So now the root, we know that it lies between 2.5 and 2.753. So we continue this way until a given number of finite steps. I am not sure when this is going to converge. Perhaps we are in the next video. I will show you how we can, write it in Python, like write an algorithm, so we'll be sure that it is converging. For this pen and paper, it is quite a laborious process. I'm not so sure whether I really want to go ahead, but you can try this out for maybe 1, 2, 3, 4, 5, 6, just for 3 more steps, just to be sure that you have understood the logic, especially of this update and where the root is going to lie. So you can terminate after the next 3 steps if it is not converging. Okay, all right, so thank you. In the next video I will write an algorithm for it, and then we'll be sure that it converges, and then we shall also discuss the advantages and disadvantages of such a method. Okay, thank you so much, and see you in the next video.